question number 8. All right. So question number 8, guys, wants us to determine the maximum or minimum of a quadratic function. All right. So essentially, when you want to find the maximum or minimum of a quadratic, we need to first know what a quadratic function looks like. All right. So a quadratic function is represented by something called a parabola. All right. A parabola is either a U or an N shape. All right. So whenever there's a U shape, that means that your leading coefficient is positive because it's facing upwards. All right. So again, because this is facing upwards, all right, this means it has a positive leading coefficient, all right, or a positive LC. Okay, that means the number in front of the equation would be positive. Okay, whenever it's facing downwards, so again, whenever it's facing downwards, okay, that means you have not a positive leading coefficient, but a negative leading coefficient. All right, and you're probably wondering, how does that help me? Well, whenever you have that U shape, whenever you have a positive leading coefficient, that means the vertex, which is where all points meet, will be at the bottom. All right. So again, your vertex is at the bottom. Because your vertex is at the bottom, this is called a minimum vertex. All right, because it is at the bottom. It's the lowest point. Okay. So because this vertex in a N shape is at the top, what do you think that's called? Yup, it's called a maximum vertex. Okay. So again, guys, whenever you have a negative number in front of your equation, all right, that means it's going to be facing downwards, all right? That means it has a negative leading coefficient, all right? So for example, for this question, because we have a negative number at the front, that means it will be a negative leading coefficient. That means it will have a maximum vertex. All right, so for this question, we have a maximum vertex, okay? So let's find out what that maximum vertex is, all right? Whenever you have vertex form, which is the form that we see right here, all right, we know that we can represent it looking like this, where it's y equal some leading coefficient, parentheses x, some number, parentheses squared, some number. All right. In this case, the number we have here is a positive 5. In this case, the number here is a positive 5. Okay. However, to represent that vertex, you always do the opposite of the number inside the parentheses and then the same as the number on the outside. Opposite of a positive 5 is negative 5. Same as a positive 5 is positive 5. And this would be the coordinate for that vertex. However, it will ask you what is the maximum. The maximum will be the y value of that vertex, which is the 5. All right. So again, this 5 would represent the maximum value of your vertex. Okay. So when you see it in delta, you would write that it's a maximum. All right. And the maximum value of that vertex is 5. Okay, so let's try the next one. Okay, so we see that it's not in vertex form right here. So again, this question right here was given in vertex form. All right, this question right here looks a little different. All right, it's actually given in standard form. All right, so this question is given in standard form. Okay. However, we can still figure out if it's going to represent a minimum or a maximum by looking at the leading coefficient. Because the leading coefficient or the LC is positive, what type of vertex would that be? Yup, a minimum vertex. All right. So again, this one will have a minimum vertex. Okay. So let's calculate what that minimum vertex is. Okay. So for this question, we're going to use the formula that x is equal to negative b over 2a and then plug it back in to find that minimum value. Okay, so at times I'll set this up like negative 1 parentheses over 2 parentheses And you're probably wondering, what are these A's and B's that I'm talking about? Well, your A is your leading coefficient, your B is a coefficient attached to your X, and your C is your constant, all right? So instead of B, I would plug in 9. Instead of A, I would plug in 3. And now I would calculate, okay? -1 times 9 is -9. 2 times 3 is 6. Now I'm going to do -9 divided by 6. So -9 divided by 6 is -1.5. All right? So I will get -1.5. But I'm not done yet because I need to plug it back in to find the y value of that vertex. So I would rewrite my equation, and I'm going to replace all my x's with what? With a parentheses. And what's going to go inside of that parentheses, guys? Yup, the -1.5. Good job, guys. All right? So now I'm going to calculate, guys. So again, you can put all this in your calculator, but I'm going to use my small calculator to do the same thing. So I would do -1.5 squared first, because in order of PEMDAS, all right, so again, in order of PEMDAS, okay, parentheses comes first and then exponents. We can't calculate anything inside of the parentheses, so now I'm going to do the exponent. So -1.5 squared is -1.5 multiplied by -1.5, which will give me positive 2.25. All right? Then I'm going to multiply it by the coefficient in front. So I'm going to multiply it by 3. And I would get 6.75. Now I'm going to multiply 9 by -1.5. And I would get -13.5. Okay? Because again, a positive times a negative is a negative. And a positive 4 I'll bring down. Now I'm going to calculate. Okay? So 6.75 minus 13.5 will give me -6.75. Then I would add 4, and I would get -2.75. All right? And that would be the y value that would represent my minimum. Okay? So in delta, what you would put, okay, so again, in delta, this is what you would put. You would put that this represents a minimum. So again, it represents a minimum, and that minimum value is the -2.75. So that makes sense because a minimum means that you're lower, all right, and a maximum means you're higher. So our minimum is a negative number while our maximum was a positive, all right? So let's try the next one, guys, all right? So for this question, guys, it's not given in vertex nor standard form. We see 2 pairs of parentheses, so that tells me that it's given in what type of form? Factored form. Good job, guys, all right? Because anytime you see 2 pairs of parentheses, what form is that? Factored form. Good job, guys, okay? So I need to convert this from factored form to standard form so that I can use my formula, okay? So again, just want to put an underline that this was where I got this answer right here. So let's go ahead and let's get our standard form by distributing, all right? So firstly, I need to remember that in front of here is a -1. I'm going to bring down that -1 for right now. Now I'm going to go ahead and FOIL, which is distribute. So I multiply the x by the x, then the x by 2. X times x is x squared. X times 2 is positive 2x. Now I'm going to distribute the -1. -1 times x, -1x, or -x. -1 times positive 2 is -2. Now I'm going to combine any like terms. The only 2 like terms I see is the positive 2x and the -1x. All right? Everything else I'm going to bring down. Okay? So everything else you're bringing down. So I'm going to bring down the x squared. 2x minus 1x is positive 1x or positive x. And the -2, I'm going to bring it down. Now I can distribute the -1 that's in front. All right? So -1 times x squared is -1x squared or -x squared. -1 times positive x will give me negative 1x or negative x. Negative 1 times negative 2, a negative times a negative gives me a positive 2. Alright? And again, guys, in front of here is a negative 1. In front of here is also a negative 1. Now, I can use my formula that x is equal to negative b over 2a. And guys, we actually forgot to represent if this was minimum or maximum. Well, because the number in front, the leading coefficient is negative, what does that mean? So if it has a negative leading coefficient, that means it's facing downwards, and it is a what type of vertex? A maximum vertex. So again, this here represents a maximum vertex, okay? So let's find what that maximum vertex is, okay? So again, your A is negative 1, your B is negative 1, your C is 2. So I would have negative 1 parentheses over 2 parentheses. And what am I going to plug in for B? Negative 1. What am I going to plug in for A? Negative 1. Alright? Negative 1 times negative 1 is positive 1. 2 times negative 1 is negative 2. 1 divided by negative 2 is negative 0.5. So again, guys, 1 divided by negative 2 will give me negative 0.5. Alright? But I'm not done yet because I need to not find the x value of the vertex, but the y value. So I'm going to rewrite my standard form equation because, again, right here is the standard form. Okay? And I'm going to replace all the x's with a parentheses. And what do you think is going to go inside of that parentheses, guys? Yup, the negative 0.5. So inside of here, I put a negative 0.5. Inside of here, I put negative 0.5. Now I'm going to calculate. So I'm first going to do in order of PEMDAS exponents. So negative 0.5 squared, alright, is negative 0.5 times negative 0.5, which will give me positive 0.25, okay? Then I would multiply it by negative 1, which will actually give me, so again, if I multiply that by negative 1, I would get negative 0.25. So I just made this negative. Alright? Negative 1 times negative 0.5 is positive 0.5. Because again, 1 multiplied by any number stays the same, but a negative times a negative gives me a positive. And a positive 2 I'm going to bring down. Okay? So now I'm going to calculate. Okay? So I'm going to do negative 0.25 plus 0.5 plus 2. And I will get 2.25. Alright? So that means my maximum, so again, that means my maximum, alright, would be represented by that 2.25, which is this number right here. Alright? So again, guys, just like that. And I knew it was maximum because the leading coefficient, or the LC, the word LC, guys, means leading coefficient. So again, LC means leading coefficient, alright, which is the number in front, okay? Because the leading coefficient was negative, that means it was facing downwards, that means it has a maximum vertex, alright? So good luck, guys, good luck.